Hello everyone. So we are going to look at bitset in C++. So let's start bitset in CPP. Yeah. So let's say that if we have a Boolean array, let's say if we have a Boolean array in C++ of size 10, how many bytes does it need? So to store one Boolean value, it takes 1 byte, correct? So we have 10 Boolean values. So total number of bytes will be 10 bytes, correct? Now my question over here is, uh, let's take 10 size array. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, maybe it is one more. So when we write index in the array, we start from left to right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Let me erase this. Perfect. Okay. So we have a 10 size array, Boolean array. What can we store here? If it is a Boolean array, either we can store 0, 1 here, 0 denoting false, 1 denoting true, right? It's a Boolean array in C++. 1 means true, true means 1, 0 means false, false means 0. So we are using 10 bytes to store 10 Boolean values. But my question over here is, do we need 10 bytes to store 10 Boolean values? If we have to store 0 or 1, 1 byte is enough to store 0 or 1, right? 1 byte can store either 0 or 1. So if we have to store 10 Boolean values, it's a waste of memory over here. Why? Because to store 10 Boolean values, we can store it in just 10 bit. But right now, how many bits are we using? For storing one Boolean values, we are using 1 byte, and that is equal to nothing but 8 byte. So instead of using, sorry, it is not 8 byte, 8 bit. But to store one Boolean value, we are using 8 bit, but we just need 1 bit to store, right? So now let's discuss about bitset. So to declare a bitset, what you have to do is you have to write bitset and then the size. Size is compulsory. That's the disadvantage you can say about bitset. You cannot take a dynamic bitset. You have to declare a size. Let's say BS is the name. So size, bitset, size, and the name. This is how we declare a bitset. Now, if we declare a bitset of size, let's declare a bitset. So this is how we declare a bitset. Now let's take an example. Let me declare a bitset of size 10. Let's name it as BS. So this time, if we declare a bitset of size 10, it will reserve 10 blocks of memory. Yeah, but the difference you can see over here is exactly what you can store in this array, you can store the same information in this array. But now if we compare the memory, how much memory this bit set is taking, it is taking by 8 times memory compared to the Boolean array. Okay, the Boolean array was taking 80 bit. This is going to take just 10 bit, right? But we can store the same information. One more thing, in bit set, we give the index from right to left. So the first bit, that is also called as LSB, least significant bit, will be always at 0th position, and MSB will be at size -1 position. Okay, this you can also compare as, let's say if we take a decimal value 10, how do we write 10 in binary? We write it as 1010, that is nothing but 8 plus 4, 8 plus 2, that is 10. So if we have to write this 10 using a bit set, it will go from here 0 1 0 1 and rest all zeros. So you can compare this LSB, that is 0th bit, with the 0th bit here, and this MSB with the last bit. Okay, so we start indexing it from right to left. Now one more thing, let's say if we have declared a bit set, how do we access any block of information? Like, let's say if I have to access the bit at 0th position, I'll just write it similar to an array. I'll write BS of 0, and it will give me whatever value is there at that position. So you just have to say BS of any index, and that is going to give you the value at that index. There is another way also to retrieve the same information. You can also write bs.test. This is a function. Here you need to pass the index, and it is going to give you the information at that position. Okay, so if we write, let's say BS of 5, it is going to give us the value which is at index 0 1 2 3 4 5 here. If I write 7, then it is going to give me exact value what is there at 7th position, and it is always 0 1. You can treat 0 as false, 1 as true. Okay, so you can also use either test function, or you can use index directly as you use in array or vector in C++ to get the information, right? There is another way of declaring bit set. While declaring bit set, you can also pass a value. Let's say here if I say 16, okay, so what it is going to do is it is going to convert this to binary. So right now we have 10 bits, right? The first bit will be 0 in 16, second, so 16 if we have to write it, it will be nothing but 2 power something. So let's say 0 1 2 4 8 16. We've used 5 6 7 8 9 10. Yeah, this bit set will look like this. So you can either declare an empty bit set, or if you give some number, it is going to convert it to binary, and it is going to initialize your bit set with this. Now here if I write BS of 5, it is going to give me 1 because I have to write it 4 because index starts from 0. So if I write BS of 4, it is going to give me 1. Okay. Now there are many functions and there are many advantages of bit set. Let's try to code it. So we'll take standard library std c++.h. Let's take an example. Bit set of size, let's say 20. Yes, as I said, if I give here some values, let's say 17, and how do we print it? Okay, so if you are going to print the whole bit set, it is going to print to all the bits. Okay, let's print it and see. So 17 is nothing but 16 plus 1. So 0th bit is set and the 4th bit is set. Okay, now if I don't give this 17, what is going to happen is it will print all zeros. Very simple. Okay, so if I don't give the value, I don't have to give the parenthesis as well. Yeah, so all zeros. Now, as I said, you can access any index. Let's say I'm taking the same value 17. You know that the 4th bit was set, so you can get that value by just passing the index. Okay, similarly you can use bs.test to get the same value. Okay, so this both should give us the same value because we are using the same index 1 and 1, right? That's clear. Okay, now there are a lot of inbuilt functions. We'll quickly go through it. So let's say if I write bs.count, it is going to give me how many bits are set. Okay, count of bits which are set. Now let's say if I write ps dot none, what it is going to do is it is going to tell you whether all the values are set or not set. If all the values are not set, it will give you true, else it will give you false. Gives false if any of the bit is set, else is. Similarly, there is one function called in. Okay, so this one works just opposite to the previous one. If any of the bit is set, it is going to give you true. Give return true if any of the bit is set, else returns false. Return would be more suitable, right? Now one more thing. Yeah, what do you think? What should be the answer of count? There are 2 bits set, right? None. Are there none of the bits set? No. There are bits set, so it should give us, what should it give? It should give us false, and this should give us true. So 2 false and true. Let's try it. 2 false and true. Yeah, exactly. Yeah. One more thing, like if you want to set all the bits to 0, what you can do is you can write bs dot reset, and it is going to reset all the values to 0. But if you want to set all the values to 1, you want to set all the bits, then you can write set, and it is going to set all the values to 1. Now with this, actually you can do one more thing. Let's say if I want to reset just the 5th index, so I can pass 5 over here, and it is just going to reset the 5th index. It will not touch the other index. Let's say I want to set the fourth index. So I can write here 4, and it is just going to set the fourth index instead of setting all the index. Okay, so let's print this and see. Here it will set off reset all. Here also it will be reset all. Then it will set all and then set the fourth. Okay, so because here only it has set all, here there will be no change. Okay, there are a few more interesting functions. So let's cover it quickly. bs.flip. If you write this, it is going to flip all the bits in the BS. So it will make 0 as 1, 1 as 0. So it was all ones, right? It converted it to all 0. Right? Okay. Now the advantage of using bitset is you can do many operations on bitset. Like you can perform bitwise operation, you can perform left shift, right shift. So let's see this. If I write BS left shift one time, what happens if I shift the bit towards left for one times? Okay, I'll comment out these all things. What will happen if I shift the bit towards left? It actually gets multiplied, right? And moves towards left. So yeah, you can see here initially our value was 1001, and now if I shifted it one towards left, it become 1001. Yeah, sorry, this is not right. Yeah, now we'll get the correct. So BS left shifted one times. Yeah, this is the right value. It shifted towards left for one time, right? You can also perform OR, XOR, many operations here. And one more most important thing over here is all these operations are takes constant time. So these are very fast. Okay. You can solve a lot of coding questions with the help of Bitset using less memory and very fast. Okay. That's all for this video. Thank you.